All right, so here we are. We're going to go over our Chapter 4 quiz here in Science 9. And so I know this is kind of small for those of you at the back to see, but I will go over every question and every answer. So let's take a look at, first of all, Section A. It says match the key term in column 1 with the choices in column 2. And what I'll do is maybe I'll just make this one just a bit bigger. There we go. Okay, so element. All right, what do you suppose element is? Well, of all of these definitions, element should be D, a pure substance made of only one kind of particle that cannot be broken down by chemical means. So that is D. All right, so here we go. So number 1 is D. Okay, a pure substance, only one kind of particle cannot be broken down by chemical means. That's an element. The second one is, chemical property is E, the ability of a substance to react.
Nice E.
You like that E? Adhesion. Adhesion. That's going to be B, the ability of a substance to stick to another substance. That's B. Physical change, a process in which particles of a substance are rearranged. That's going to be C. And a chemical reaction is the process in which a completely new substance is formed. Chemical reaction. That's correct. Any questions about that? Now, for your test, or you're studying for your unit test, you should make sure that you have, if you're not sure of these terms, you need to study these terms, put them on a cue sheet or something like that to study. Cool. Question?
So when my dad printed off.
All right, section B. Place the letter of the correct answer in the space provided. What is polyethylene?
C.
Polyethylene is a plastic. It is C. That's right. Okay, polyethylene. That is a plastic. Number 7. What does the study of chemistry deal with? The answer is B. Understanding and changing matter. Yes. 8. Combustibility is the ability of a substance to do what? Go ahead and shout it out if you know.
Quickly with oxygen to produce heat and energy and light.
That's right, it's A. You've got it. So to react quickly with oxygen, that's something will combust and react with oxygen. To break apart, not quite. Form a flammable substance, no, it's not. That's a slightly different. Support burning. That's more talking about the fuel and oxygen and what you have to sustain burning, but combustibility is the ability to react quickly with oxygen. Okay, as we move on, let's see this one here. Okay, so number 9, how many different states of matter exist?
4.
Okay, so we've talked about solid, liquid, gas, and a plasma. So yes, the answer here is C. How is salt water classified? How is salt water classified? Element, compound, solution, or suspension? Salt water. Let's see. Who votes for solution? You are correct.
Yeah.
Salt water is a solution. That also is C. Which of the following is not a physical property of a tree? Physical property. It's solid, dark brown, over 2 meters tall. It can make its own food through a process called photosynthesis. That's right. D. Well, here's the thing, guys. Remember, a physical property is a description of the matter itself, whether it's color or mass or volume. A descriptability sort of thing. Solid, physical. Brown, color, physical. 2 meters tall, quantitative, physical. Its ability to perform chemical processes would be a chemical property. So this is a chemical process that would be referring to a chemical property. That's why it's D. Number 12, which of the following is a chemical property of oxygen? It is, okay, so clear is a color. Combustible is how it reacts with other things. Colorless, that's color. Gas, that's the state of matter. So the only one that is actually a chemical property, you're right, is B. B, a chemical property. All the others are physical properties. Why did I say B and right? Okay, B. Somebody said D on me?
I think I mixed you up.
Well, thanks a lot. Totally messed me up. Okay, yeah. I was just looking at my B from the backside. That's why I wrote it that way, yeah. Okay, 13. Which of the following is a chemical change? Wow, chemical change. Garbage rotting. Carrots being chopped. Dissolving drink crystals in water. Ice melting. Yep, it's A. I heard you guys shout at A. That is correct. Let's see if I can write A correctly. There you go. Haha, funny. Okay, A is correct. 14. What does the formation of a precipitate? Ooh, precipitate. I don't know if we've talked specifically about precipitate in class. You would have looked that one up. So in these quiz assignments, you have to look up things that maybe you don't remember or things that we haven't written down in our notes. But a precipitate is something that kind of falls out of a solution or something that's kind of generated. So what does the formation of a precipitate indicate?
Change of state.
I thought it meant precipitate.
Okay, which one is it? A physical property, change of state, physical change, chemical change?
B.
Okay, this is a tough one. A precipitate is when something kind of comes out of solution. Something new is created.
Oh.
So this is a chemical change. It's actually D.
Come on.
Yeah. It's yes. You can change your answers here. Yeah, make your corrections. This is part of your studying now, so definitely.
I just put a note.
Yeah, you can put a note there, whatever, as we go over this. No problem. Okay, yeah, that's a tough one. A precipitate is something that comes out of solution. So if you mix two things together and all of a sudden you have this milky, sort of powdery thing forming at the bottom of your solution now, that is a precipitate. That's something that's been drawn out or that's fallen out of the solution. So it is a new substance that's formed. Chemical change. Number 15. What does the term photodegradable plastic refer to? Photo is your key. Degrade. Okay, so some of you are saying B for 15. Who votes B? Yeah, it says that plastic that can be broken down through exposure to sunlight. That is photo, the sunlight, broken down is degradable. So it is B. That's bad news, that stuff. Bad news.
Not good. I got 5 out of 10.
Okay, well, that's all right. You're learning. Okay, what else we got here? Let's... okay, last page, is that right? Your last page on this? Okie dokie. Section C, matching questions. All right.
Oh gosh, I probably screwed on this.
Okay, so matching questions here. 16, hydrogen. Boy, you look at this over here. What do you think goes with hydrogen?
C.
C says an example of an element, definitely. The other ones, mechanical mixtures, physical change, fuel. Okay, so hydrogen, an example of an element would be your best answer there, absolutely. C. 17, fire requirements. Okay, what is required to have a fire actually burn? Yep. Right on, that's letter A, fuel. So that's like something to be burned, oxygen, and heat. So you need some kind of heat to start the fire, is kind of what they're going for there. So fuel and oxygen are the big things, but you got to get it started with some kind of friction or heat. So that's the other important piece. Okay, food digesting. What one would go with food digesting? We've got C is gone, A is gone. An example of a chemical change?
Yes.
I would agree. D.
Why? I know it is, but you.
Why? Okay, so food digesting, your body is breaking down the food and turning it into either energy or waste product, right? So when your food is digesting, it's definitely not remaining the same, right? If you eat your broccoli, it does not come out as broccoli, right? So there's a pleasant thought, A, and B, it maybe helps us understand that digestion is a chemical process. Something new and unpleasant is being formed. All right, erasing an answer.
B.
Oh, that's interesting, erasing an answer. Boy, is messing up an option here? Nope, let's see. B, an example of a physical change. You guys think it's an example of a physical change? I would agree. B. It's there, and then, so if you erase an answer, does it disappear?
Yes. No,
Ooh.
it does leave a trace.
Yes, no?
But to the eyesight, it can leave.
Okay, so it leaves a little bit of a trace. Okay, so I guess you're kind of, basically your eraser is kind of picking up those little graphite particles and putting them in the little, the eraser kind of like bits, right?
Yeah, it is.
So you're just basically removing them. You're kind of crushing them together and brushing them off to the side. Yeah, sure. Okay, 20, fireworks. So is fireworks, is that an example of a mechanical mixture or fuses knowledge of chemistry to create beautiful displays in the night sky? Wow, that's kind of a tough one, yeah. F. Beautiful displays in the night sky. I'm not really sure vinegar and oil salad dressing would qualify as a beautiful display in the night sky, so yes, F is going to work for fireworks. And obviously, vinegar and oil salad dressing is an example of a mechanical mixture. Yes, it is separable. You can separate those things. They look differently, and there we go. CADBFE is your solutions there. Awesome. Okay, section D. List 3 physical properties of water. Let's hear some of your options. Let's see. Yes? Okay, okay, that's interesting. When it comes in contact with an object, the object becomes wet. Okay, so how can we I'm going to challenge you a little bit here. What sort of properties of water makes other things wet? What are some of the properties that in your textbook that we talked about? Words even that have been in this quiz. Anybody else? Yeah?
2 hydrogen, 1 oxygen, like the hydrogen.
Okay, well let's follow this thought here. Okay, I like what you're saying. What happens when something gets wet? Water actually sticks to it. Okay, so what property is that? Adhesion. Cohesion. Water sticks to itself. Adhesion, water sticks to other particles and other things. I would suggest that maybe adhesion is a great adhesion. That's good. It makes things wet. I think I like that. Cohesion as well. That is true. Did you guys know that something called hydrogen bonding is what makes ice less dense than water? That's why ice floats, because the water molecules actually arrange themselves in such a way that, well, I guess, is this cohesion? I suppose water molecules sort of attach or stick to each other in a sense. Anyways, cohesion sticks to itself. Anything else? What are the properties of water? And again, you can check your chart in your textbook there. What else do you have written down? Yep.
Me?
Yep.
Okay, so I said that it.
Okay, it's liquid at room temperature. Sure. Liquid at room temperature. Room temp. Ooh. Okay, something like that. Yes. Any more? Let's get more than 3 here. Go ahead. Yeah. The color. It's color. Okay. What color would it be? Would it be colorless or transparent or opaque or what? Okay. Well, I guess it depends on the state. Okay. So you could talk about its color. Maybe you'd say it was colorless or something like that. Okay. Anything else that you think really should be on here? Yep.
I said reflective. I don't know if that's
reflective. Okay. I like that. If you look at the water and you see a reflection of something on the other side of the lake, it's reflective. Okay, I like that. Sure. That is definitely talking about its the physical property, right, of how light bounces off of the particles. Sure, reflective. Okay, just one more. Drinkable. Drinkable. Okay, I think there would be probably some chemical properties of water that would make it drinkable. So I'm not sure that would be a good answer for this one. That would maybe be referring to its chemical properties. Does that make sense? If it's drinkable, that means your body can handle it, can use it, can process it. Yeah. Okay, there's probably many others there. Let's move on to 23 though. Okay, there would be some more. If you want to check with me later, you could. Describe 3 properties of water that make it useful in everyday life. Okay, what makes it useful? Now, let's go back to drinkable. Okay, your body needs it to hydrate itself. Yeah, it makes it useful. Okay, reaction with, your body, I guess. You could talk, that it's necessary for your cells to operate. Okay, properties of water that make it useful. Now, I think they're going for other things, but what else would you say there? Okay, what property of water makes it good for cooking? Because cooking is an everyday life thing that's really good. Yeah. What properties of water would make it good for cooking? Okay, boiling it for pasta. Oh, awesome. Let's say boiling point. Do you know why I want to say boiling point? Because, well, it's low. That would be a relative term. But it's high enough that you can actually heat water to cook your pasta. So the boiling point is high enough that it can hold enough heat to cook things. Perfect. Some more here. Okay, so along with boiling point, maybe the melting point. Okay, so it can be frozen easily. So melting point, and again, you would expand on these, melting point and boiling point. You know, it would hold enough heat to cook food. Melting point, it's easy to get to a low enough temperature that it can keep other things cold. Okay, so freezing is easy, which keeps food from spoiling, or helps you if you have a sore knee. It takes swelling down. So the fact that we can get it to a solid relatively easy is awesome as well, involving the melting point. All right, so adhesion in a sense that we can make things like salad dressing, or you can think about the surface tension of water. Even bugs and insects, they can actually kind of walk on the water because they're so light, and there's surface tension. That would be maybe cohesion for that. The ability for it to sort of bond with its own self. Okay, all right, great. This is great. I like this thinking. Amazing. Okay, 24, why is it important to take action to reduce the use of plastic items? How does the use of plastic affect the environment? So thinking now about our environment, what sort of thoughts do you have about that? Yep.
It's not very
Okay, so it's not easily degradable. Okay. Organic things will break down and degrade fairly easily, but plastics take long time to break down, which means that it can kind of get stuck in our environment for a long period of time. Things can accumulate, and as you said, it can affect wildlife. It can affect even the quality of our water and our soil. Like when these plastic chemicals leach into our water supply, that's not a good thing. In the oceans, there's these big floating garbage dumps right in the ocean that affect the water, affect the wildlife, all sorts of things. So I like that one. Yeah, good. Any other comment on that or a different one? Okay. The energy and resources to create. Okay, good. The energy, I like that. Energy and resources to create. Now, I would argue, and probably a lot of people would argue, that it's worth it to spend the energy and resources to create some plastics. That would make our life quite difficult if we didn't have some plastics. Now, whether you agree with that or not, life would be maybe more expensive. Life would be not as easy for us. Okay, so if we didn't have plastics in our life, I wouldn't be able to show you anything on the computer screen here. I wouldn't be able to use any of this without plastics. It'd be more expensive to have milk in glass bottles than it would be to have in plastic bottles. All the sorts of electronics that you use without plastics, there's no electronics. Okay, so you can't even listen to me right now, watch this video. You can't even do anything like that without plastic. So yes, I like the thinking. We have to be careful and steward the resources in this world well, absolutely, in order to be responsible. So we do have to consider the balance that we must strike. Excellent. All right, here's your chapter 5 quiz. Let's talk about this one as well. Column 1. Okay, so let's figure out what metalloids are. We're talking about the periodic table. Well, there's no F, so it's not F.
I meant E.
Huh. I'm confident to say that F is the incorrect answer.
It looks like F on my
Okay, elements that have metallic and non-metallic properties. That is correct. E, not F, but E. Very good.
It's because the bottom line was into the line.
Yeah, okay, I gotcha. Electron. What's an electron? Ooh, I'm seeing number C. Number C, I like that. What's an alloy?
A.
A mixture of two or more metals.
D. A. And then next one's D.
Yeah, you're welcome. So we got A.
D.
Atomic number is atoms of the same element with a different atomic mass. The number of, B. Hey, not now. Let's do this. Isotope is, what's the only one left? D. That's right. Atoms of the same element with different atomic masses. All right. Section B. Let's keep going. Number 6. Which element will react violently with water?
D.
Violently. Let's see. Carbon. What is this one? Cu.
Centrifuge.
Centrifuge? Nope. Yeah, copper. Yes. Centrifuge. What's Fe?
It's iron.
Iron is correct. And calcium. So do you think the answer is?
Calcium.
It is calcium. D is correct. All right. Number 7. Okay, guys. I know this is very exciting. Quiet down, please. Thank you. Which person or people believed that matter was made of earth, fire, water, and air?
A.
Number 7 is D, the ancient Greeks.
Great, I hate
D. Okay. Try and keep your negative comments to yourself. Thank you. 8. Which of the following is not a part of John Dalton's atomic theory? Let's see. All matter is made of small indivisible particles. Oh, that's part of it. All atoms of an element are identical in properties such as size and mass. Yeah? You think so? Yep. Atoms of different elements have the same properties. Oh, that looks like it. Atoms of different elements can combine in specific ways to form new substances. Yep. So it looks like 8 is C. This is incorrect, Amundo. C. Next page. Which scientist designed the gold foil experiment? That would be? Yes, Uncle Ernie. Ernest Rutherford. A. Which particles have similar relative mass? Okay, guys, listen. Which 2 particles have similar mass?
C.
Protons and neutrons. The answer is C. That's correct. Which of the following sets of elements are metals? Metals.
C.
So you want to think back to the periodic table there. Somewhere. Where do I have the periodic table? Oh, goodness. Forget it. So in the left or the middle part of the periodic table. So which one did you say? C? C is correct.
C is correct. Yay!
Isn't that science fun? All right. Number 12. Okay, turn around. Which of the following sets of elements are gases at room temperature?
B.
Gases. You think B?
Yes.
Oxygen, fluorine, argon, xenon, chlorine? I think you're correct. B. Calcium is a metal solid here. We've got sodium as a solid, aluminum as a solid. So, okay, 13. Which element has an atomic mass of 238? Uranium, that's right. Very radioactive. Uranium-238. So you would check your periodic table for a lot of these ones, right? How many electron shells are shown in a Bohr diagram of lithium? So you've got the nucleus. You've got one ring that has 2 electrons. And how many electrons does lithium have? It has 3. So we have to have how many rings showing?
3.
Well, there's 3 electrons, but 2 rings. So it's B.
Oh, wait, yes, I got it right.
So remember, the question says how many electron shells or rings, the circles. Electron shells represents the circles, not the electrons, but the circles. So there's only 2 circles, 2 electron shells.
I'm gonna fail.
Probably. Number 15. Yeah. I'm just joking. Which of the following would most likely contain the highest concentration of heavy
B.
metals? Okay. This one you might have to look up in your text, right? Read about this. Okay, I'm hearing D. Any other answers you think?
B.
D is correct. Large lake trout. D.
Isn't that because they go closer to the
Yeah, that's right. All right, section C, matching. 16, fluorine. What would you say is the correct response for fluorine here? D is correct. Its atomic number is 9. It's number 9 on the periodic table. What about mercury? Mercury. The symbol comes from the Latin word hydradrum. Yeah, sure. F, I like it. Not sure if I said hydradrum right. Okay, 47.87. What might that be?
C.
The atomic mass of titanium? Correct. Number 19, AU. It's the short form of awesome.
A.
No, it's not. It is the symbol for
Gold is awesome.
gold. Aurum, shining dawn. Number 20, what is 22? 22. The atomic number of titanium is correctamundo. Okay, that's a great cheer. 21, the only thing that's left is E. Awesome.
My rules are getting worse.
Okay, let's talk about these. Okay, so compared to gold, everyone listening? Compared to gold, sodium is a reactive metal and has a low melting point. How does atomic theory help us to understand these properties of matter? Okay, what are some guesses here?
Okay, this is just guess. Can I just read what I put?
Yes, please, read what you put.
This helps us understand the world.
Okay, so there's a couple things that I'd like to mention here for number 22. First of all, atomic theory, if you think about Dalton's atomic theory, because gold and sodium are different elements, they would have different properties. Okay, so different elements have different properties. Now, the other thing that we talked briefly about here was the periodic table. If you think about gold and sodium on the periodic table, here's a quick little diagram, just an outline of the periodic table. Okay?
Because he's been studying it for his whole life.
Pretty much, yeah. So gold is AU, and that's right around here. Okay? That's where gold is on the periodic table. Sodium is number 11, and it's right around here. So because they're both metals, they might have some similar properties. Okay? But what can we say about this? The elements that are in the same column, the vertical columns, generally have similar properties. These are in different parts of the periodic table, therefore their properties are a little bit different. So we can say they, I would just represent that by saying that these elements would have different qualities because they are not near each other in the periodic table. That's another thing you can say. So compared to gold, sodium is reactive metal and has a low melting point. Okay, because sodium, and now I don't know how much we talked about this, but because sodium has one electron that's on its outer shell, it likes to give away that electron quite easily. Remember when we talked about sodium becoming positive very easily? And that's because it wants to give away the electron. Gold has a lot of electrons. It doesn't want to become an ion very readily, and so it's less reactive. Okay? So you could say the number of electrons for bonding and where they're positioned. So this is another thing you could mention. Number of electrons for bonding and their position in the element. Okay. And you could also just say that there are different places in the periodic table, so they would have slightly different properties. All right, there may be others. You can talk with me after if you wish. Number 23 and 24 are the last two questions. So I'll just read you what I've got just for the sake of time here, okay? John Dalton proposed an atomic theory to explain the nature of matter. J.J. Thomson determined that all atoms contain electrons. Ernest Rutherford demonstrated that there was a dense positive nucleus in each atom. James Chadwick came up with the idea of neutrons. Should any one of these scientists be given all or most of the credit for modern atomic theory explained? So everyone kind of contributed something a little bit different to our modern understanding. Kind of like a puzzle. They're putting kind of puzzles together. So each scientist's discoveries, though, depended on someone else's contributions. So it's really difficult to say that one person should be given all the credit for the atomic theory. Instead, probably all of them, because this was a puzzle and it really doesn't make sense unless the puzzle is together. So we probably should think about giving all of them credit, even though they only each discovered pieces.
And they kind of build off each other, too.
Okay, just let's conclude here. So some of you said that perhaps that Dalton deserves most of the credit because he was the one that made the biggest contribution. You know what? Maybe. I would say that because the way science is done, that everybody adds to someone else's discoveries, that everyone really should be contributed. So wait, not going anywhere yet. 24. Get your stuff out. We're not done yet. Silicon is a metalloid. Why is silicon a good choice for making semiconductors in electronic devices? Refer to silicon's properties in your response. You should have something like this. Just check your response. Metalloids such as silicon are semiconductors. They do conduct electricity, which is very important, but not very well, making the flow of electricity easy to control. Silicon is a solid also at room temperature. Those are important things. So make sure you have those things, and I'll write those things down here before you go.